So today we're going to start talking about electricity. And this is a very large section in the Gordon-West manual, so we're going to spend a few days learning about this. So one thing you need to know about ham radio is that ham radio involves a lot of electronics. A lot of circuits are required in order to make the radio and all the accessories work. And even if you don't actually build anything with your bare hands with electronics, which actually you could do, many people make their own antennas or accessories. And there are even do-it-yourself radio kits where you put together your own radio out of all the circuit components. But whether you do that or not, you do need to know some stuff about electricity. And especially, you notice this drawing up here. You want to make sure also you don't get electrocuted. And we'll talk about that more in the safety section. But anyway, we're going to learn about electricity, hence this drawing up on the board. So today, specifically, we're going to learn about three big concepts in electricity. We're going to learn about voltage, current, and resistance. And these are the three big principles in electronics. So to understand electricity, electricity is a lot like water flowing down a stream. Except instead of a stream, electricity obviously uses a wire or something on a circuit. And instead of water, the thing that's traveling through the wire is electricity, or electrons, which is what electricity is made out of. But some things are actually the same. Electrons in a wire behave very similarly in some ways to water flowing down a river. So think about it. Now, when water flows down a stream, it has a certain amount of force, right? If you're sitting in the middle of the river and the river's, the water's coming this way, there's going to be a certain amount of force that's pushing you. And electricity has something similar. Now, it's not really the speed of the electricity, whereas in a river, the force might depend on the speed of the water. But electricity does have an amount of force to it, in a way. And the force of electricity flowing down the wire, similar to the force of water flowing down the stream, that's what we call the voltage. The voltage is force. This is the electromotive force that causes electron flow, causes the electrons to flow down the wire, the electricity. Now, volts are obviously measured with a voltmeter. Volts are measured with a voltmeter. That's how we hook a voltmeter up to the circuit, then we can tell how many volts is in the electricity, in that wire. So now let's think about another thing in a stream. Now in any stream, in any river, there's current, right? There's current in the river. The river's, there's current coming this way. There's current flowing down the river. The current is the amount of water sort of flowing in the stream. And it's a little different from force. Whereas force is the force of the water, the force, current is just the amount of water going down the stream. Now, force and current, they might depend on each other. If you have more current, you might have more force, or vice versa. But they are still two different concepts. And there's also this concept of current in electricity. And it means exactly the same thing. Basically, the amount of electricity flowing down the wire. And current, we have here, current is measured in amperes. That's the unit for current, or oftentimes we abbreviate this as amps. And there's one more thing we need to know, which is finally we can look at resistance. So resistance is a little harder to explain in terms of a river, but it's not really that hard of a concept. So in electrical circuits, we have what we call a resistor. And a resistor, basically, it resists the current from flowing. It sort of slows it down, hence the name resistor. And it lessens the amount of current flow and it increases the resistance. Resistance being resistance from the flow of electrons down the wire. So resistance is measured in ohms. Resistance is measured in ohms. And to measure resistance in a circuit, we use an ohm meter. Just like we use a voltmeter here, and actually we use an ammeter to measure current. Resistance is in ohms, we use an ohm meter. So how exactly do we measure voltage and current though? So voltage is measured in volts, and current is measured in amps, as I said. So in other words, the more volts you have, the more force of the electrons there is in the wire, and the more amps there are, or the more amperes, the higher the current is of electricity. So, but how do we actually measure these things? As I said, we have these meters. Voltmeter measures volts, ammeter measures amps. But how do we connect these things to a circuit? How do we connect these meters to a circuit to actually measure the volts and amps and ohms? And in electricity, there are actually two ways that you can connect things to a circuit. And if you've taken a course in physics or electricity, you might know about this. But basically, you can connect things in series, or you can connect them in parallel. So when you're connecting things in series, basically there's a circuit. Let me see if I can draw this here. So let's say this is a circuit, okay? And this is the power source. Let's say this is the battery. So if things are in series, then there might be something here, here, and here, and the current goes in series. It hits this thing, then it goes to the next thing in the series, and the next thing, and that's why it's called in series. Things are in series that way. But there's also something where we have in parallel, where we have another wire that's sort of going like that. And we might have things here instead of over here. Now things are in parallel. So in parallel, there are parallel connections. Things aren't all in series, whereas series is like a long, stretchy road where everything's on that road and the electricity hits everything on that road. A parallel circuit is sort of like having many different roads that are all connected with the main road or the main wire. So the electricity will go over here on sort of the main road and power this thing, but it'll also sort of some of it will go this way, some of it will go that way, and power these components in the middle here. And that's a parallel connection. So how do we connect voltmeters and ohm meters and ammeters? Specifically, voltmeters and ammeters is what the test is concerned about. How do we connect those to circuits? Well, it's a bit complicated. Voltmeters, you're actually supposed to connect those to the circuits in parallel, like this. Whereas an ammeter is connected to the circuit in series, which is the other thing we talked about, where you don't have these parallel lines. You just plug the ammeter in the middle somewhere in the big circuit. So this is sort of hard to remember, so I made sort of an abbreviation. So voltmeter is in parallel, VP, voltmeter parallel. Ammeter is in series, AS, ammeter series. So if you abbreviate this, you get VP and AS. And I made this into a little acronym. The vice president is Adam Smith. The vice president is Adam Smith. VP, voltage parallel, Adam Smith, AS, ammeter connected in series. So if you remember that the vice president is Adam Smith, then you should be okay in terms of these questions that you might run into on the test. All right, so now that we've talked about voltage and current and resistance, sort of VCR, now we can go on to talk about something else the test will ask you about, and that's about batteries. So there are going to be a few questions about batteries on the test, since this is obviously related to electricity. And specifically, the test will ask you about which types of batteries are rechargeable. It'll give you a list of batteries and ask which types of batteries are rechargeable. Now, I have a handy trick for you here. Almost all batteries that the test will ask you about are rechargeable. The only battery type you'll see on the test that isn't rechargeable is the carbon-zinc battery. The carbon-zinc, I believe that's written somewhere here. Anyway, the carbon-zinc battery is not rechargeable. Any other battery that it asks you about is rechargeable. Yes, here it is. Carbon-zinc batteries aren't rechargeable. Any other battery they ask you about will be rechargeable. So this is all you really need to remember for all the questions about rechargeable batteries. So now let's talk about one final thing. And that's electricity in your car. In other words, oftentimes hams operate ham radios in their car. And they plug the car needs to supply power to the ham radio somehow. So you need to get the power from your car into your ham radio. So most mobile transceivers, mobile radios that you'll have in your car, they require about 12 volts of power. Remember, we just talked about volts. That's the force. They have a requirement. They need exactly roughly 12 volts of power in order to work. If they have less than that or more than that, they're not going to work. They need 12 volts. Mobile transceivers need 12 volts. Luckily, most car batteries are already 12 volts, which is perfect. So what we usually do is we actually hook the radio straight up to the battery. We run a cable from the radio and it goes through the hood sort of, and it connects right to the battery. And it gets the power to run right from the car's battery, which is pretty handy. Now, there's something very important that you need to know for the test about this, and it's actually pretty obvious. Now, you probably already know, you've worked with probably AA batteries, AAA batteries. You know that batteries have a positive and negative connection on them, right? And similarly, these radios, they have cables. One cable connects to the positive terminal of the battery, one cable connects to the negative terminal of the battery. Now, obviously, the negative connection of the radio's power cable connects to either the car's battery at the negative terminal. Obviously, it would need to connect to the battery, right? Because it's to power the car. Sometimes you can also connect it to something called the engine block ground strap. I'm not going to explain what that is. If you remember that, obviously, a power cable usually connects to the battery, you'll be all right as far as the test is concerned. And that's pretty obvious. The power cable needs to connect, obviously, to the battery in order to get power. Okay, so we're almost done. There's just a few things we need to know. And the test is going to ask you some questions about electrical conductors. So depending on how much you know about electronics, depending on maybe you learn about it in school, you probably know a little about electrical conductors. They're things that conduct electricity, things that electricity can flow through them, like metal. Now, copper, which you probably already know, is a great conductor of electricity. Copper is almost like metal. So it's a great conductor of electricity. Electricity flows through it very easily. Okay, another thing you may or may not have learned about is alternating current and direct current. So we're going to talk about these, AC and DC. And if you haven't learned about these, I'll go through them. So we talked about current, how it's basically the flow of electrons through a wire. Now there are actually two types of current that you're going to see in circuits. And the first type is alternating current. So alternating current is a little weird. And this is where the analogy of a river sort of starts to fall apart. Because with alternating current, the current actually reverses direction multiple times per second. So in other words, if we look at a stream, the water would be going this way 1 second, and then all of a sudden it changes and it goes this way, and then it changes again, and it kind of goes back and forth like this. It keeps changing direction. Obviously, this doesn't happen in a river unless maybe there's an earthquake. But in electricity with wires, this happens all the time with alternating current. It reverses direction all the time. That's why it's called alternating. It's alternating direction. The only thing is, alternating current has a little problem with it. Most appliances run on DC power, not AC or alternating current power. So DC stands for direct current. Now the power in your house is alternating current. The power that comes out of the sockets in your house, that's alternating current. But appliances run DC, they don't take AC, so somehow we need to turn this AC current into DC current in order to get everything to work. Now this is where a rectifier comes in. So what is a rectifier? Well, a rectifier is used to rectify this problem. It rectifies this problem by turning AC current into DC current. And this is how you can remember what a rectifier is. It rectifies the problem of appliances not accepting alternating current. So anyway, they turn it into DC, which is called direct current. And direct current is current that only flows in one direction. It goes directly from point A to point B. It goes in one direction, no flip-flopping around. It's like a river. You know, a river doesn't change direction. It just always goes in one direction. That's like direct current. Direct current always goes through the wire in one direction. It doesn't alternate directions like AC power. So finally, there's this one more final thing we have to learn about, and then I'll let you take a break. We have to learn about something called a diode. And a diode is an electrical component that's often on circuits. Now, a diode does many things. It's usually used to as light indicators to light something up, such as like the power indicator on your laptop. That's the thing that lights up the power button. That's a diode. That's a light-emitting diode. But for the test, you need to know that diodes, they're a little strange. And for some reason, they only let current flow in one direction. So when electricity is passing through a diode, it can only go one way. It can only go, say, this way. If it tries to go, if it tries to go this way, the diode won't let it go the other way. So obviously then it can only take direct current. It only lets current flow in one direction. Now a diode, like many things in electronics, many components that you're going to put on circuit boards, a diode has what we call two electrodes, meaning it has two places, two little wires where it connects to the circuit. So these two electrodes are called the cathode and the anode, the cathode and the anode. The diode has a cathode and an anode. So electricity basically goes into the cathode and it goes out of the anode in the diode. So let's say, let's say this is a diode here, and this is the cathode, this is the anode. So it's going to go into the cathode through the diode and out the anode, and then back into the other components on the circuit. So we're going to look at pictures of a diode later in the picture this section in the Gordon West manual, which is, I believe, a couple sections off. But pictures of diodes on electrical diagrams and schematics, which we're going to look at later, they usually show an arrow that's pointing from the anode to the cathode. And because of this, you might think that since diode pictures show the anode going to the cathode with a little arrow, that the electricity flows that way. But actually that's wrong. The current actually flows the other way for some strange reason. So on electrical schematics, and we're going to learn about this later, so don't worry if you're confused right now. We're going to look at this more in detail. But on electrical diagrams, the cathode on a diode is usually labeled with a little stripe on electrical diagrams. There will be a little stripe, like a vertical stripe like that. And that's how we can tell that, that it's the cathode. The cathode is labeled with a stripe. Okay, so I think that's more than enough today. Why don't you take a well-deserved break, and then we'll continue on learning about electricity.